Let us look at proposition number 1 of book 6 of Euclid's Elements. The proposition says that triangles and parallelograms which are under the same height are to one another as their bases. Okay, so here we have two triangles under the same height. So we have to prove that these two triangles and any parallelogram with the same height would be in the same proportion to the bases. Okay, so first we let's create the uh, parallel line to BD at through A. Okay, so we know how to do that. So circle, circle, intersect, and a line. Now that we have the line, let's hide this. Now let's draw a line parallel to AC through B and then through D. And let's mark the points of intersections as E and F. And let's join these points so that we can hide the lines. What's next? Let us now extend BD, and on this line here, let's mark a point which is equidistant to BC, or rather the length of that segment should be equal to BC. Let's draw a circle. Let's mark the point of intersection. Again from G, again we mark one more point which is equal to where that point and G, the distance is equal to BC. So circle, intersect. So now we have HG. Let's hide the circle. Now let's hide the circle. Okay. Now let's join these points to A. Similarly, from this side also, equal to CD, we will mark a segment here, and again one more segment here. So K and L. Let's join these points to A, and let's mark this parallelogram BEAC and CAFD. So we have two parallelograms, and these parallelograms are also under the same height. So our construction is complete. We know BC is equal to BG is equal to HG. That is how the construction went. We know CD is equal to DK is equal to KL, and we know BD is parallel to EAF. Based on a proposition from book 1, we know that triangles between the same parallel lines are equal to each other. Of course, they should also be on equal basis. So here BC is equal to BG is equal to GH. So these three triangles are between the same parallel lines and on equal basis. So we can say that this triangle is equal to this triangle is equal to this triangle. That is triangle ABC is equal to ABG is equal to AGH. So which means, remember, CH, these are all equal. So CH is equal to 3 times BC. And the area of these triangles are also equal. So when we say triangles are equal, basically we mean the areas encompassed by them are equal. So since these triangles are equal, we can say that this ACH triangle is equal to 3 times triangle ACB. So that means CH and this triangle ABC are equimultiples of ACB and BC. So we can say that CH is to CB as triangle ACH is to ACB. Now let's come to this side for this triangle. ACD is equal to ADK triangle is equal to triangle AKL. Why? Because again, these triangles are between the same parallel lines and have equal bases. So now CL is equal to 3 times CD and triangle ACL is 3 times triangle ACD. So again, we have the same multiple 3. So we can say that CL is to CD as triangle ACL is to triangle ACD. So what does that mean? It means if CL is greater than CH, then triangle ACL is also greater than ACH. If it is equal, then equal. If it is less, then less. But ACL and ACD are multiples of ACB and ACD. So we can say if CD is greater than CB, then triangle ACD is greater than ACB. Same is the case with equal to, less than. So which means we can say CD is to CB as triangle ACD is to ACB. So we have shown that the triangles under the same height are to one another as their bases. Now let's look at this parallelogram. Parallelogram BEAC is 2 times this triangle, again based on a proposition in the first book. And CAFD is twice the triangle ACD. So again, there also these two parallelograms are equal multiples of these two triangles. So which means triangle ACB is to triangle ACD as parallelogram BEAC is to parallelogram CAFD. Okay, what does that mean? It means, remember, we have two statements now, one with respect to triangles, one with respect to parallelograms. So we have CD is to CB is equal to triangle ACD is to ACB. And triangle ACD is to ACB as parallelogram CAFD is to BEAC. So X equally, if we see, then we can say that CD is to CB is equal to parallelogram CAFD is to BEAC. So we have shown that the triangles and parallelograms which are under the same height are to one another as their bases. So that was proposition number 1 of book 6 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share it. That's it for now.